Hey everyone, geophysicist Stefan Burns here. Breaking news, there has just been a huge volcanic eruption in Ethiopia, specifically the Afar region, and this is quite striking because Africa typically doesn't get volcanic eruptions, and if it does, it occurs usually in the Congo. Though we do have the African Superplume welling up underneath the eastern part of the continent, creating the East African Rift Valley. And well, this really isn't surprising because pressure has been building here for decades. We saw a lot of activity a little further south near Dauphin and Fontal volcanoes in the past few months, like 6 months ago, 12 months ago. There's a big magmatic dike intrusion. We had steam explosions, big earthquakes up to magnitude 6, showing that overall activity was increasing, though it may have been below the surface more so. Now we have it expressing, and this is the first volcanic eruption that has occurred from this volcano here, Hayli Gubii, in more than 10,000 years. That is the first recorded volcanic eruption in recorded history as far as we know. Here we see that ash plume rising up. There are 1.5 million people that live near these volcanic systems in and around the East African Rift Valley. So if this was to really evolve, this could become quite a serious situation. Though we're looking at geologic time here. So most of these volcanoes have low viscosity magma. They don't have these big explosive events. That's kind of what we had today. Here we also see it from more zoomed out satellite view. We see that ash cloud right there moving over Yemen, and that has occurred just in the past day. About past 12 hours, this has happened. And this is going up to 10,000 feet, 3,000 meters. It's likely risen a bit more than that since we got those initial estimates. And again, the first recorded eruption in 10,000 years. Here we can look at our satellite imagery thanks to Google Earth. And here we have Hayli Gubii volcano, one of many in this volcanic zone. If you scroll around here, you'll see a bunch of other volcanoes as well. So it's not like it's the one big baddie of the area. It is really, honestly, one of the smaller volcanoes. This is Shield volcano there, but it seems to be the culprit for this big ash plume coming up. And you'll see just how twisted and churned up this landscape is because of the African superplume rising up underneath the surface. So this whole area has been very, very active. If we go down here, we'll see some of our other volcanoes which have been active recently. Let's type in Dauphin volcano. And this is where we had this big dike intrusion in between this and Fontal volcano. So not super close by. We see that it's separated by some distance here. We can measure that out using the measure tool. And so we go from right about there to there. So about 450 kilometers away from each other. But the African superplume is very active across this entire area. It's a huge geologic feature, one of the largest on the planet. We can check that out right here. Here we see across two different cross sections of the African superplume, but specifically I want you to look at this one going from A to A dash. And this shows overall the seismic velocity, whether it's fast or slow for Africa. And you see this area right there where it's very slow velocity. This is the P wave that we're looking at. So the compressional wave for a sound wave. And when it's low velocity, it means that it is overall more malleable and hot, and it's a low velocity seismic province or zone, and it's usually linked to volcanism. Here we can see the cross section with depth. So we see that African superplume coming up closer down here to like South Africa, like in this zone. And then you see how it starts to actually go up, and then it becomes a river of lava across the surface. And this is actually breaking the continent apart. So continents are the hardest and most stable geologic structures that we have on the surface of the planet. They're made up of certain rock types, typically like felsic rock types that are very, very strong, and they're not easy to break apart. Think granite, right? And well, this flow of energy up from depth is so powerful that it's actually causing the continent to rift apart, and most of that energy is concentrated right there in the Afar region of Ethiopia, and then going a little bit further down as well, and even there's a bit of activity going into Arabia. So this is what's happening right now with Africa, and we've been seeing this pressure building now for not just months, but years, even decades. And now we're finally starting to see big explosive eruptions from this rifting zone in the Afar region, which doesn't usually have them. It is a volcanically active area. You can go back to the 2010s to 2020s and find different eruptions, but it's not the most common. They are fairly infrequent compared to, let's say, like Hawaii, another volcanic plume system coming up, right? It's having eruptions basically like clockwork right now in 2025. So this is what's happening. You have this huge amount of energy and convection and flow from the core mantle boundary, and exactly why is a good question, likely related to the geodynamo and deep inner earth processes, but we really don't know why. And then it comes up and it starts to move laterally. You get decompression melting where the pressure drops, and then you get this rock to effectively start to melt and liquefy, you could say, forming these magma chambers very close underneath the surface. And then when they repressurize, it's like popping a pimple basically. And then boom, you get some action going up. So that's what's happened here. 20% of the volcanoes that are known in the East African Rift System, they showed activity, signs of deformation and things of that nature going from 2015 to 2020. So in a 5-year time span, that's it, just 5 years, there was a huge amount of activity across those 18 volcanoes, representing 20% of the total number known. There's also subsidence and more. The area is very active geologically, energetically, and again, as I said, 1.5 million people live in and around that area. We know a lot of what we know about this because of isotope ratios. Specifically, helium isotope ratios are very, very important for tracking where this energy is coming from, because we know that there are different helium isotope ratios down near the core mantle boundary, and they are brought up from depth as a result of mantle plumes like Hawaii and the Superplume here in Africa. So helium, remember, is the second lightest element right behind hydrogen. It's a noble gas, meaning it's not that reactive, right? It doesn't really bind to things. And this allows it to migrate up from the deep earth. And when you find these high He3, He4 ratios, like those observed in Ethiopia, then you know that has a very deep origin. And well, that's exactly what we see. We see different ratios going across this rift zone, but you see that they're very, very elevated in this Ethiopia dome region, the Far zone. So this is where we had that eruption just recently. And again, this is a big eruption. Just check out that plume on the satellite imagery going out like this. So this is a developing story. I'll keep you up to date on what is happening here. We track everything that's happening energetically on the Earth. That's earthquake activity, volcanic eruptions, geophysical events like geomagnetic storms. We also look at solar activity, space weather, planetary resonances, and cosmic forces and events as well, as many of you know. So if you like the sound of that, then please subscribe, smash that like button, and help the channel grow. Thank you all so much for watching. I've been your host, Stefan Burns. I'm wishing each and every single one of you well. Hopefully this activity cools down, but the longer trend here is that it's actually building up. So this is our first big depressurizing event, you could say, in a while. We'll see if that continues. I'll keep you up to date. Thank you and have a great day.